Let's look at this section of the exponent logs packet. Identify A, B, H, and K. Sketch the graph of each function. Determine if it is a growth or decay function. Label the horizontal asymptote, the K value, as a dashed line. Label the y-intercept and H, K plus 1. State the domain and range. So before we do the example 21 here, let's go back to the Exponents manual notes from the rubric page on Canvas. So let's review what discontinuities are. We have removable discontinuities, holes, jump discontinuities for like piecewise functions, and then infinite discontinuities for asymptotes. A hole is a break in the function that can be filled in with a point. They're found when variables cancel out the numerator and the denominator. You'll do that with rational functions in another unit. Vertical asymptote. The vertical dashed line on a graph that the function never touches, like this. Set the denominator equal to 0 and solve for the variable. You'll also do that with rational functions. Horizontal asymptote. The horizontal dashed line on a graph that the function never touches. This is the one that we'll do with exponential functions. Vertical asymptotes is what you do with logarithmic functions. And then together, you'll do both of those for rational functions, which is not in this unit. And then we have oblique asymptotes. Asymptotes that are neither vertical nor horizontal. They can be diagonal, slanted, or a curve. Those also you can find with rational functions. So the only two we'll be dealing with in this unit is vertical asymptotes for logs and horizontal asymptotes for exponents. Here's some examples of exponential growth and decay. We look at the base. This one is less than 1. It's between 0 and 1. That's why it's decay. A 7 is greater than 1. That's a growth. 3/2 is greater than 1, a growth. -4, that's neither. If you graph it, you'll see what I mean. And then 0.26, that's a decay because that's less than 1 and greater than 0. Also, notice that the exponent for each of these examples is positive. If this x were to be negative, if it said negative x instead of just x, these would all be reversed. Okay, here's some examples on graphing exponential functions. Y equals 3 to the x minus 2 plus 2 has a domain of all real numbers. All of these exponential functions will have a domain of all real numbers. This is a growth, it's increasing. The range will have from y is greater than 2. It doesn't actually touch 2, but it'll be greater than it. The end behavior, it's going from 2 on this side to infinity on the right side. The horizontal asymptote is y equals 2. The x-intercept, there are no x-intercepts here, and then the y-intercept would be 0,19 over 9. To get this number, you just plug in 0 for x and evaluate to get y. Your transformations from the parent function, we have right 2, up 2. Right 2 is from this h value right here. Up 2 is from this k value. And then here's a table of values. And then for our other example, we have y equals 5 times 1/2 to the x power. That is a decay. It still has a domain of all real numbers. The range is going to be y is greater than 0 because there's no k here, so k is 0. In behavior, on the left side it's positive infinity. Right side is approaching 0. The y values. Your horizontal asymptote, y equals 0, just whatever your k value is. And then x-intercept is none. Y-intercept is 0,5. Again, to get the y-intercept, just plug in 0 for x, evaluate. Alright, let's look at number 21 in our packet. We have y equals 3 to the x plus 2 power plus 2. Our a is the number that's in front of the base. It's just 1 because there's no number there. The base is 3. The h is negative 2. It's always the opposite of what's up here. And then the k value is a positive 2 from right here. Let's go ahead and write out that formula. Y equals a times b to the x minus h power plus k. Okay, this base is bigger than 1, so it is a growth. Our h, our horizontal asymptote, is y equals 2. It's just whatever the k value is. The y-intercept, we have 0, comma, and if we have 3 to the second plus 2, that's 9 plus 2, that's 11. So 0, comma, 11. And then our range would be y is greater than your horizontal asymptote. Y is greater than 2. So that means we have from 2 to infinity for interval notation. Domain is all real numbers, negative infinity to positive infinity. Go ahead and try the other examples on your own for these characteristics of exponential functions, and then move on to the next section.